My name is Chris Lehnig. I'm a PhD student in the Computational Sciences program at San Diego State University. My advisors are Drs. Karen Campbell and Jose Castillo, who are both co-authors on the poster I will be presenting at the ACSESS event. We are currently studying risk dynamics of events called surface expressions, which are unexpected subsurface to surface flows of hot oil, water, steam, debris, and rocks that are believed to be associated with oil wells that use cyclic steam injection to help produce heavy oil from diatomite formations. These events may appear at the surface as small leaks or big eruptions, launching fluids and materials hundreds of feet into the air. We are using 17 years of high precision surface deformation measurements derived from tiltmeter arrays to investigate risks in 2 study areas located in 2 separate oil fields in the San Joaquin Valley. Our 2 study areas have experienced more than 70 surface expressions over the last 30 years. In the remaining slides, we will look at the temporal and spatial clustering of surface expressions and tiltmeter surface deformation patterns in relation to event locations. These maps show the cumulative net deformation of the tiltmeter surface over a 17-year period in each study area. Red in these maps indicates uplift and blue indicates subsidence. Event locations are shown with magenta circles. These maps show that surface expressions are spatially clustered in areas of most extreme cumulative tiltmeter surface deformation, both in regions of highest uplift and regions of lowest subsidence. In the timeline at the bottom for each study area, arrows point to each month that an event occurred with dots indicating the number of events. In both study areas, the frequency of events has increased with time. Here we show the greatest observed uplift and subsidence of the tiltmeter surface that occurred at any point in study area A over 17 years. We have added to these maps the bottom hole location of all drilled wells as of June 2021, shown as gray circles. In the southeast region of the field, surface events were spatially associated with more dense clustering of bottom hole locations and were observed in regions that experienced the largest subsidence. In the northwest region of the field, surface events followed a different pattern and were spatially associated with the regions that experienced the largest uplift. Looking at similar maps for study area B, surface expressions were again spatially associated with areas that experienced both the largest uplift and the largest subsidence of the tiltmeter surface over the 17 years of coverage. Similar to the events in the southeast of study area A, the events in study area B are also spatially associated with more dense clustering of bottom hole locations. Spatial clusters of surface events were associated with areas of extreme uplift and subsidence and were often associated with more densely spaced bottom hole locations. The cumulative view of tiltmeter surface deformation in each study area provides a sense of the relationship between surface expressions and tiltmeter surface movement dynamics. The findings presented here are observations from a more extensive study currently investigating the spatial and temporal scales of risks by correlating tiltmeter data with field activity data. Thank you for watching my video, and please see me at my poster to further discuss these results.